Alright. First off, my wife was here yesterday. She left a lovely surprise. My wife came in and I asked her if she remembered this, and she said, yeah, and then turned her head and she said, wow, it looks like a Christmas tree. And then she decorated it as a Christmas tree for you all. Cute. Oh, Christmas tree. Alright, from here.
Elijah Smith, please report to 1071.
So in this, we left off this idea and we got the field order. I showed you this option of how to get the field order, but then I also mentioned to you my personal way of doing it. And this is the thing. How you find the number is dependent on which block of the periodic table you're in. So if you're in the S, P, D, or F, it matters. For the S and P blocks, it's simple. For the S block, the number equals the row. And the same thing for the P. The number equals the row. But then you have a change. When you get to the D and F block, everything changes. D, the number, is equal to the row minus 1.
Elijah Smith to 1071.
And F, for the F block, the number is equal to the row minus 2. So that's the key whenever you're trying to find these out. So the field order in this, and hopefully you guys can roll through this quickly with me, and so that you all have it. Welcome to the periodic table you will see so many times now throughout this year that you will be ready to burn every periodic table you see in your life. So those coming around. So just coming around. So in this, we talked about this and breaking it down, okay? Broke it down really fast. We didn't get everything in enough time yesterday towards the end. We didn't finish the periodic table down. That periodic table is coming around. Whenever you get the extras, just set them on top of my laptop. In this, we talked about how you get the number. And to get the letter that goes with it, it's literally the block that you're in. So in this case, just starting off the periodic table, right here, hydrogen. Said the first thing you need to worry about is this helium actually sits right over here next to the hydrogen in this case. But it sits over there because it has like 9 different reasons why it fits over there better. So in this case, whenever you're running through it, what row is this? 1, thank you. So in this, we're going through 1. Which block did we just go through? S, so 1S. After 1S, and you literally drive this like it's a road map. What row are we in? 2. So if I go into 2, 2S. It's 2S because it's the S block. It's the second row. From 2S, we go to
F. No, F.
Oh, so
I don't remember. I don't understand how you're getting. There was one I was working up yesterday.
this is S block. Columns 3 through 12 is the D block. Columns 13 through 18 is the P block. Then you have these two down here by themselves. These are the lanthanides, actinides. They are the F block. That's where the letters are coming from.
Did we write this on this paper?
That's your choice.
We'll get Millie of them anyways.
Alright, from here, we've went through 2P. What comes after 2P? You're back here at what row? 3. I got one person saying 3. Thank you, Hunter. I go through what block?
S.
Which makes it what?
3S.
3S. Then from 3S we go
3P.
3P. If you have no idea how I'm getting this, this is where you look at me and say, Mr. Hall, I have no idea where you're getting this. What?
You didn't turn the camera.
I know I didn't.
Okay.
It's because it's on the other video.
Okay.
Just going once. Hi. If you don't understand where it's coming from, just ask me. Like, is everybody good? Is everybody seeing how I'm getting the number? I explained up there how I get the numbers. Everybody seeing how I'm getting the letter? It literally comes from the block that you're crossing. Okay.
So all, sorry.
Go ahead.
So each 1, 2, 3, 4, 5, 6, 7. That's all like not like the layers, but it's the stuff that we go through.
Energy levels.
Energy levels, yeah.
You'll learn about that next time.
Okay.
The 2 at the bottom, 6 and 7, right? Also.
Yes, and how do you know it's 6 and 7? Because of these numbers right here.
Yeah.
Alright, so from here I go through the 4th row. Where do I go?
That's 4S.
Then I go from there into here. What's this?
3D.
3D. Very good. Why is it 3D and not 4D?
Because you said subtract 1 from the row.
Subtract 1 when you're in the D. Number equals row minus 1. Question. I cannot hear you.
No, I was just saying in my head.
Guys, this is the point. Like, if you have a question, I cannot help you without you telling me. I cannot read minds. Like, I look at the room and I'm asking if there's questions, and I'm getting looks at me and faces like, I have no idea what he's talking about. And I keep asking if you have a question, and I keep getting looks that say, I have a question, and then nobody's asking a question.
It just looks so strange. It's not really a question. It's like,
All right, so from 3D we go what?
4P.
4P. Then from 4P we go to the 5th row.
5S.
5S to
4D.
4D to
5P.
5P. Questions? All right, let's get freaky. Go to 6.
6S.
What's after 6S?
Would we go to the D or the?
You come down. 57 through 70. You come down to the lanthanides. So we go what?
4F.
4F. Then after that, you come back up because you end at 70. You come up to 71. And you go
5D.
5D to
6P.
6P. And then you go to
7S.
7S. And then we drop down to the actinides and you go
5F.
5F. And after 5F, you go
6D.
6D. And then you go to
7P. I'm going with 3.
7P. So it's great to know Hunter's got it. Hopefully everybody else does.
I know that stuff. I just.
Then you should have said something, Riley. I was the only one giving the answer.
Because I'm trying to figure this out, Hunter.
Yeah, it's 5. F number equal row minus 2. Okay? So in this we have 2 more rules. So we have the Pauli exclusion. Principle we still talk about. Pauli exclusion principle states something that's not going to make no sense to you right now, but will later on. In this it says no 2 electrons from the same atom can have the same 4 quantum numbers. make more sense later on to you. All this is saying is that those electrons, they cannot share locations. Their locations are set, they're finite. Okay? It's kind of like Hunter is sitting in that desk. Since Hunter is sitting in that desk, is it possible for me to sit in that desk? No, it's not possible for me to sit in that desk. Okay?
Let's go. Let's push me here.
Yeah, I ain't fit. Don't worry about that. And then the last rule we got to talk about is Hund's rule, which is the one that a lot of kids struggle with. And they forget it for some reason. Hund's rule. Hund's rule is crucially important. And it states that orbitals of equal energy levels. Sure.
Yeah, she's
Each gain one electron before any of them gain a second one. What?
He isn't like that ugly, but he is like ugly. You know?
That's ugly.
Like he's not like attractive, but he's not like, oh my god, he's gonna break a mirror.
Looks like a serial killer.
He does. He does look like a serial killer.
He looks like a macho.
He kind of looks like a frog.
I told you, he looks like a toad.
I think you're just being ridiculous.
We're all entitled to our opinions.
I mean, I just don't think he's the ugliest one.
Maybe that's fine. You
I've
want
seen
to
ugly.
look up and see
Yes.
if he's got any great grandkids that you can hit up and ask out, go for it. As for me, we're all entitled to their opinion. Like, hey, my wife is the most beautiful girl on the face of this planet. I'm a blessed man. Whoever was married to Wolfgang Pauli, well, they were punished for their entire life.
It's cold. It's cold.
Listen, it's okay. My wife is being punished. She's married to me too. I mean, my goodness. Okay. Now, here comes the fun part. I'm going to be completely upfront and honest with you. This is going to make no sense to you whatsoever until it finally clicks. And then when it clicks, you're like, oh my gosh, I may actually pass a chemistry quiz.
I did a while.
There is hope.
Probably not.
There is hope.
I do believe I heard that at the beginning of this class, at the beginning of the year.
Are we done yet?
No,
All right.
No, we all failed.
Hey, and to my opinion and my credit also, like, let's also remember that I told you that you've never experienced something like this before.
Mr. Hall,
Yeah.
Emily Cook has signed out.
Good deal. Thanks for letting me know.
there is
I'm with the Christmas tree. Alright, so in this, we're going to start working on these. Okay? And we're going to start with the first one. We're going to introduce it today. And it's called orbital notation. This is the one that is the hardest and most complex. That's why we start with it. First important aspect to know is that orbitals are represented by an underscore, which is just a blank spot. Okay. Probably should have said this in second period. Probably helped. electrons are represented by arrows that point up and down. The reason we have the arrows pointing in opposite directions like this, because must show spin.
Is that in purple?
Huh?
Is that in purple?
Yes.
Okay.
Those are for electrons that are in the same orbitals. They have to point in opposite directions. Why do they have to point in opposite directions? Is what do like charges do? Attract or repel? They repel. Now what is up with everybody today? Well, it's like in the second period.
I was
like,
answering
dead
everything
also.
on there. I will give other people a chance.
I just want to
Okay, anyway. So they repel. So if two negatively charged subatomic particles were in the same area together, they're naturally going to repel. So how can we get them to stay in there? The electrons actually spin, and the spin of those electrons give us an electromagnetic attractive force that cancels out the repulsion force so they can stick in there together. Which we get to go into quantum entanglement and everything later on. So in this, anyway, so the electrons are represented by arrows, and here's some more important information. You need to think about the orientations. So the orientations, you have, think about it for every one of the blocks. So for the S, P, D, and F. There are so many orientations for each one of these. For the S, there's only one orientation. For the P, there's 3. For the D, there's 5. And for the F, there's 7. So now in these, that's how many blank spots they get. That's how many orbitals they get. So for the S, it's 1. For the P, it's 3. 1, 2, 3. For the D, it's 5. 1, 2, 3, 4, 5. For the F, it's 7. 1, 2, 3, 4, 5, 6, 7. Now here's the keys whenever you're labeling these. You're going to find out what I'm talking about labeling in a second. Whenever you're labeling these, you better label them properly. So in this, you label them in the middle. So for the S's, it doesn't matter. There's only one, so you just label it right there. For 3, you label in the middle. 5, you label it in the middle. For F, you label in the middle. That right there is where you're going to label to identify what these are. That's where that, like, the 4F, 3D, 2P, 1S, all that stuff is going to be labeled there, telling me which of these subshells it is. It tells me what orbital is. It gives me all the information. You best not label here, here, or any of these spots. Where you see me writing the word label, you best label there. If you don't, it is wrong. I'm making that known right now because for the last 3 years of teaching, I've had kids that have labeled that wrong, and I haven't counted off for it, and it's driving me insane to the point where I can't handle it anymore. If you don't label it properly, you are wrong. I'll also say this: if you need to, shake yourself. If you need to, stand up, because it's like I'm looking around the room and I'm getting some looks that look like y'all just drank half a bottle of NyQuil and you're ready to pass out, which tells me you're not listening to me right now. None of this is being absorbed. You're having no idea what's going on, and later on you're literally going to come in here freaking out and you're going to fail this quiz. And honestly, this is a quiz that you should take off and sort.
I have a question.
Yeah.
What exactly will we be labeling? Like, will we be putting arrows there or what?
No, the arrows will go here. So since you asked, I'll show it to you. So like the arrows can go in these spots. That's where your arrows will go.
That's like a weird one.
Those are arrows. I do half arrows so that they don't collide with each other. You can do a full arrow or a half arrow. Half arrow.
Is it just all up or up and down? All
They're up and down.
All of them?
Not all of them.
Just one of these.
Up, down, up, down, up, down.
What about the last one, number 3? Is that just blank?
Yep.
Okay.
Still have to show them even if they're blank.
Okay, so 1 is up, down. 3 is up, blank.
No. Don't look at it like that. Just stop. You're going to mess yourself up. We've now hit the point where everybody's trying to figure something out, so we just need to do these.
Please.
The goal is for you to get an idea of what's going on. I'm not looking at you and saying you're going to master this today. So in this, you can choose an element. Normally I let a kid choose the element, and they always pick uranium. I'm like, I'm not doing uranium. Y'all driving me nuts. Because that's going to go on for all day. We're going to start very simplistic and easy. We're going to start with our good old, most common element in our atmosphere. Hydrogen. Number 7 on the periodic table. In this case, I'm literally going to show you how I do this. I find the element I'm looking for. So in this case, I look, I go, hey, where's nitrogen? Oh, it's number 7. Boom, there it is. And then I mark through everything that I go. So I went through the 1s, the 2s, I go to 2p, but I stop because there's nitrogen. So I'm going all the way to 2p. So I stop at 2p and I mark it down. These are just my side notes. You do not have to put this information down. These are just side notes so that I know I can make my life a lot simpler and a lot quicker. So I got 2p. How far in did I go? How many blocks into the P block did I go? 3. So I marked 3. So I got 3 electrons at the end. So I'm at 2p, 3 electrons. So in this case, I know everything before that is full. So where did I go first? What did I go through? 1s. You start with hydrogen. So in this case, I got 1s. I have an electron up and I have an electron down because it's full. Y'all want to see something cool? How many electrons do I have in here? 2. How many columns is on the periodic table for the S block? 2. How many orientations or orbitals does an S get? 1. How many columns is there for the P block? 6. How many of these are there?
3.
How many columns are there for a D block?
5.
Columns?
Columns.
10. How many orientations does it get? How about how many columns for the F? 14. How many orientations does it get? You always can take the number of columns in there, divide it by 2, and get your orientations. And within that, it's important to know, inside, every orbital can only have 2 electrons. It's the maximum it can hold. It cannot hold any more. It doesn't have to hold 2, but the maximum it can hold is 2. So going back to doing this orbital notation for nitrogen, we went through the 1s. What comes after 1s? 2s. How many electrons? 2. You went all the way through. What comes after 2s? 2p. Or not 2p? Is the question? How many orientations does 2p get? 3. I am waiting on answers. Where do we label at? In the middle. So right here at 2p. How many electrons do I have that I have to represent? Huh? How far in did we go? How far into P block did we go?
We're on third one.
You have 3 electrons. You can look at every one of those boxes up there as if it's representing of an electron. So in this case, I have 3 electrons left. But this is where kids mess up and you jack up the rules. You have to remember the rules you're governed by. Hund's rule states all orbitals of equal energy will gain an electron before it comes back to get a second one, which says you have this first orbital here will get an electron. They are all in that 2p subshell, which means those 3 spaces have the same amount of energy with it. Since it has the same amount of energy with it, the electron, the next one, will not go here. It'll go here. And then it's the same thing for here. Now, how many electrons did I just put in that P? I'm done. You do not put any more. A good way to check yourself. How many electrons does nitrogen have? If nitrogen's neutral, which means it shows no charge on it, which you're not giving any of that right now, it will show, it'll have the same number of electrons as it does protons. So how many does it have? 7. Count how many electrons you're showing. 1, 2, 3, 4, 5, 6, 7. You're done. The spaz looks that I'm getting right now that you're like, what is going on? That's okay. I don't expect you to get it off first. It's a system. If you learn this system, you keep working the system, you'll be fine. Okay?
I do have a question.
Yeah.
So, if you're right there, there's only in the first 2 rows. So why is it not 3?
This is just an example. That's actual answer.
I have a question.
Yeah.
Like if we did like neon, would there be 10?
There'd be 10 electrons.
Okay. Okay.
Is that your question?
Yeah, that was it.
Okay.
I just wanted to know if it was the same for every single.
You would. There'd be 10 electrons, and then you would also have the 2p would be 4. So the 3, I'd add 3 more electrons going down. All right, from here, let's do another one. Okay? Just step it up a little bit. Honestly, when you guys catch this, you're going to keep battling with yourself of like, wait, I can't be understanding this. This is chemistry. It can't be this easy. Yes, it is. I promise you. This is this easy. Let's do sodium. Number 11. You take a minute, write down on your paper. I'll give you a couple seconds. Write down on your paper where we're going to stop. Where sodium has a stopping. Alright, in this, where do you have sodium stopping? How far in does it go? Okay, so I have one electron to show. So in this case, we're going to go through. What do we cross first? Remember, it's like a road map. You always start at hydrogen and you keep going. So what do we cross first? 1s. Is it full? So arrow up, arrow down.
How do you know if it's full?
Did you drive all the way through it? It's like here, where we stop, it's not full. It can be, but in that case, you need to stop and check it. Like honestly, what I would do right now, I'm slowing this down because you guys are not ready for this. But honestly, if I was doing this, I would literally write down every one of them and feel it until I get to 3s, and then I'd stop and look. What comes after 1s? 2s. Is it full?
Yes.
Yes, you went all the way through. What's after 2s?
2p.
So how many orientations? 1, 2, 3. Where do we label? In the middle. 2p. Is it full? Yep. Up, 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 down, down, down. What's after 2p?
Mr. Hall, why is it two?
What row?
That's the second.
Okay, second row. And which block do you go through? Okay, so in this, and this is what you're looking at. Looking at this is all we've done.
Isaac Canada to the office.
We've marked our stopping point, which is the element I give you. So it's sodium. It's number 11. So here's sodium. That's my stopping point. Since I'm stopping there, I drive all the way through it. Okay, it's like if I'm going to go to Beckley. If I take 85, I'm going to get in my car. It's got a full tank of gas. Do I have any reason to stop from here to Beckley? I'm going to keep going. So this is all it is. I'm driving to Beckley. So I go through here. What did I just go through? The S. It's an S block in what row? So 1S. Then from there, I come into what row?
2s.
Okay, so there's the second row. I'm in the S block, so 2S. Then I come over here. I'm still in the second row, but where do I go through now? So it's 2P. Okay, we went all the way through it, so it's full. And then I come here at the third row and I go, oh, I'm at sodium, so I stop.
Why did you put 3s right there?
I didn't skip. I'm happy you asked it. I didn't skip. Remember what I told you. You label in the middle of it. This right here is all 2P.
Why does 2p have 3 in it though?
I will
Sorry,
tell you, but I can't explain it. Because if I explain it right now, it's going to confuse you.
Wait, this
Okay.
is gonna sound like.
This is 2P -1, that's 2P 0, that's 2P 1. It's orientation.
This is gonna be the so is that it? Is that all you do?
No, that's not it. We're not done. I was just answering.
We're doing it so yes, but why is like. Why
Okay, hold on, because I have two people asking a question right now. One person needs to ask because you're talking so quiet and nobody can hear you. What's your question?
Did you put 3s now?
Oh yeah, 3S.
It has 1 orientation.
So how many electrons? So how many arrows?
1.
Up or down?
I do not.
Always start with up.
Okay.
That's how.
Never worry,
I feel like I don't think you have.
No, you don't need to put a box there. I put a box there to answer a question that a lot of people in this room is having, but Haley finally asked it, so thank you. Is why did I leave a spot here? Like this has no label here. The truth of it is I did label it, but I labeled it in the middle. Because if you would have done this, worse. Because then you're like, 2S, 2P, what is this? 2P has 3 orientations with it. These two are 2P. But if you give me that on a quiz, I personally promise you and guarantee you, I'm not going to sit there and look through it and try to figure out what you did. I'm marking it wrong. You did not label it properly. Since you have not labeled it properly, you are 100% wrong.
Say we put 5D, then we'd have to put like 5 lines for 5 electrons, right?
1, 2, 3, 4, 5. 5D.
Okay, I get it now. Yeah, it's working.
I think I understand.
Okay, this is the thing.
Usually don't.
Honestly, there isn't really a lot of tricks I can do with this. I mean,
Please don't.
the trick I can use is literally this. Take in the D block and the F block. And I already looked at you and I told you what you got to do. You take the row and subtract 1. You got it. This is the important thing. Tomorrow when you come in here, we'll continue on with these. And we're going to introduce in electron configuration. And hopefully, we'll get introduced noble gas configuration. Okay? Remember, Friday you have a lab. Ladies, please be planning. If you need to, make a reminder for yourself that you all need to bring hair butters. Put your hairs up.
If I
And no hairspray.